to 2 pi. Okay, so straight away we're looking at this and we're thinking about radians that we're looking at. And we're going to have to sketch the curve of 1 plus sec. So remember that sec stands for kind of 1 over cos. So it may be worth getting the cosine graph sketched in first, and we're going between 2 pi, so we can mark in 2 pi. And I'm also going to mark in this point because it's pi. These are important points, but these bits are even more so important. Okay, so these bits will give us our turning points, 2 pi, the pi, and this one up here, which is 0. We are also going to have, these points are also going to be important, so that's going to be pi upon 2 and pi upon 2 and 3 pi upon 2. Because they're when it equals 0, and obviously when we're doing sec we can't divide through by 0, so they then become important. Now for sec we end up getting, the graph goes up like this. I should probably change colour. I'll just go down and change that into a different colour, so let's go for a blue. And if I kind of go back over that, it's going to go up like that, but we're never going to get there because that needs to be an asymptote. Okay, so we've got an asymptote there. Then it ends up going back low, so it becomes a very low value and carries on. And this one loops round, and again we're going to get an asymptote there. And finally that brings it down high, bringing it in to that point there. So that would be what sec is straight away. But what we're also doing is that we're lifting this up. So we're also going to have to increase this. Now remember, this is 1 and this is minus 1. So if we're lifting it up by 1, then this one is going to become 2, and this would end up becoming, this one would end up becoming 0. Okay, and then we would also need to do 2x, which means that we're going to end up doubling, so, or halving the amount of time that it ends up taking. So instead of pi upon 2, we end up getting pi upon 4. So this becomes pi upon 4. This would become pi upon 2. This would become 3 pi upon 4. And then we would end up getting, we'd also get 2 pi over pi, which just gets us pi. So I'll just take that bit out, because if we divide it by 2 we get pi. And we're going to have to then repeat this graph again. So I've only basically drawn half the graph, then we're going to have to repeat this. So again, if we come back to this point, it's going to go up like that. And then we're going to be back down here. And then we're going to be back up the top where we kind of meet. And again, we're going to have asymptotes. Now this drawing is becoming pretty bad, but hopefully you kind of understand what I've kind of been doing there. And then it's just a case of marking in the asymptotes, which is here. Okay, so again, if we had that about pi upon 4, we should have each of the asymptotes as, again, that's marked. And again, you can sort of just see that we're going up in pi upon 4. So you just need to keep on adding on pi upon 4, and you'll get the major points all the way up through to the graph, right up until this point here, which should be the 2 pi. Okay, which means that the asymptotes are pi upon 4, 3 pi upon 4, 5 pi upon 4, 7 pi upon 4, and the turning points here, 0, if I go back over to here, 0, 2, we've got pi upon 2, 0, pi upon pi and 2, so that's pi and 2, we've then got 3 pi upon 2, 0, and finally 2 pi 0. 2 pi 2, sorry, that's up the top, so 2 pi 2. and then that would be your graph for your 6 marks. Now obviously you would probably want to be neating it up. It's just a bit hard for me to do that on this drawing tool. Okay.